Okay, so this is video 2 on phi of n is equal to phi of n plus 1. Now, of course, the last video is like, okay, so actually I already made a video 2, right? But I said many wrong things in it, right? Like factually wrong things. So, it was basically really long and so yeah, I didn't want to keep it. So basically I'm correcting it and, the correction seems pretty nice so far, right? Okay, so today, so like if you watch the last one, which I think there was a video, right? So it was like p and then p plus 1. So like p plus 1 was like 2 times q, that is single prime number. Today we'll be generalizing that a little bit, and yeah, we're not going to go much further because like I'm yet to find some like concrete proof for further cases, but for now we're going to stick to that part, right? Okay, so basically I'm going to start by proving some identities, right? So phi of p to the k, where p is a prime number. Again, yeah, that's like something which is quite intuitive, I guess. So like as I said, that's going to be p to the k times 1 minus 1 upon p, because p is the only prime factor, right? And that's going to be equal to, okay, so that's p to the k minus 1 times 1, no, p minus 1. There you go. So yeah, that's something that we're going to use extensively today. So yeah, I'm just going to go ahead and put that in the corner up here, right? And this is a trivial solution, right? So you don't consider this to be like another solution or something. I consider it something of an exception, to be honest, but yeah, so I've rewritten what we just found out here slightly. I just expanded that brackets and stuff. So yeah, basically that's. So today what case we're gonna do is this one, right? So we're gonna say p plus 1 is equal to okay, so that's gonna be, okay, so we already deduced that it's gonna be a multiple of 2. So 2 is definitely a factor. But first we're gonna start with a general 2 to the a power of a power of 2, sorry. A power of a, of course. A power of 2, right? And okay, so that's something, right? So now according to our equation, right, defining equation that we want to solve, phi of p is equal to phi of p plus 1. Now we can use this formula right here for 2 to the a, so we get, and then of course phi of p is just p minus 1. Again, I guess that's like kind of this formula. Yeah, I guess that works out. And here we get, okay, so this is going to be 2 to the not k, a, yeah, a is the power, right? 2 to the a minus 1. You can check again, it's pretty easy to check that. But okay, so the two equations we have are these, right? This is the defining equation and this is one that we deduced. Okay, so now we subtract these two equations and we get 2 is equal to 2 to the a minus 2 to the a minus 1. Oh, also just a slight note here. According to this, p is 2 to the a minus 1 plus 1 and 2 to the a minus 1. So it's a Mersenne prime and a Fermat prime. So that's pretty interesting. And I think like 4 fits both of those categories, which is pretty cool in itself. And that, as we'll see in like a second, is the only solution. 4 is the only solution to this equation. Wait, no, not 4. Yeah, a is equal to 2, which means that p plus 1 is 4, is the only solution to this equation. But I just want to point this out, right? Like, it's both a Fermat prime and a Mersenne prime. So yeah, that was a pretty cool thing, Anyways, that's kind of irrelevant to us right now, but that's just like really cool, something I had to point out. Now, of course, you can calculate this, and to get is 2 is equal to 2 to the a minus 1. This is like really easy to see. And then you divide both sides by 2. So 1 is equal to 2 to the a minus 2. Now this is 2 to the 0. So comparing coefficients or like taking log base 2, doesn't matter what to do, you'll get the only solution as a equal to 2. Implies that p plus 1 is 4, but that's a trivial solution, right? So basically there aren't any other solutions of this form. Okay, so now that that's out of the way, I'll rub that off with board, right? And okay, so now Now we're gonna take a slightly more generalized case, right? So phi of p is equal to, no, phi of p, sorry. First we define p plus 1, right? So yeah, p plus 1 is equal to, or the p plus 1, now we'll define it as 2 to the a times q to the b. And of course p and q are both prime numbers, a and b are just numbers. And of course, because 2 is already taken, then q is not equal to 2. We're assuming that, right? Because then this would be pointless because we already have the solution. So yeah, this is the slightly more generalized version. So now again you can take the you can take both sides the Euler-Tochian function, I guess. So you can use the defining equation for that, and you get that p minus 1 is equal to, okay, so now this is going to be phi of 2 to the a times q to the b. Now because 2 and q are co-prime because they're both different prime numbers, distinct primes, therefore we can write this as phi of 2 to the a times phi of q to the b. And now we use a formula. Yeah, so phi of 2 to the a is of course 2 to the a minus 1 times phi of q to the b, which is p to the k minus p to the so it's going to be q to the b minus q to the b minus 1. But I think I want to write that in like the factorized form, q to the b minus 1 times q minus 1. Yeah, I want to factor it, right? And that's just like a tendency I have. I like factored stuff better, it looks prettier. That's just, yeah, it's kind of dumb, but that's how it is. So now again we subtract this equation from this equation, and on the LHS we get 2, right? Because p, okay, so basically if you still don't get it, it's like p plus 1 minus p minus 1, right? So you know it's going to be p plus 1 minus p plus 1. These cancel, basically the difference of these. So that's going to be 2, right? You can think of it in an intuitive way, or you know, actually do it. It's pretty easy, just in case someone didn't get it. I don't want to take a risk or something. 2 to the a, q to the b, right? And then there's of course subtraction of 2 to the a minus 1 q to the b, again because this multiplies. Then this is a negative sign, but it turns into a positive sign. So plus 2 to the a minus 1 q to the b minus 1, right? Okay, let's just state that we don't want b to be equal to 0, because then, you know, this whole thing is pointless. Okay, so again you can factor out q to the b, then you get something very elementary. 2 to the a minus 1 q to the b, a minus 1 definitely, right? Okay, yeah, and then plus 2 to the a minus 1 q to the b minus 1, 2. Of course, yeah, we don't want either of the exponents to be 0, as I explained, and we want q to be an odd prime because it can't be any other prime, right? Okay, so now let's see. I think we can, like, I think I did this from here with like inequalities and stuff, but okay, so I'm gonna factorize and like divide by 2 at the same time, because you know I'm running low on marker ink, man. And that's a big problem. Plus q to the b minus 1, right? So now basically what we have is this stuff should be equal to 1. Okay, now how do we prove that it is indeed not equal to 1 or greater than 1, right, as it should be? So q would at least be 3, b would at least be 1, a would at least be 1, right? As explained previously. But of course, at this point I think it's safe to assume that should take like exponents of higher than 2 or higher or something. But okay, I'm just gonna assume that a and b are like greater than or equal to 1. Yeah, definitely. Okay, so let's form an inequality, right, with this stuff. So I'm gonna erase this boundary condition. Okay, now look at this. q to the b minus 1. Now the smallest values this could have is 3 to the 1 plus 3 to the 0, right? So that's 4, and then this is okay, so that would be so this is definitely greater than or equal to, right, 4 times, okay, so 2 to the 1 minus 2 is 2 to the minus 1, 2, and as we see 1 is greater than or equal to 2. Just state that out here, which is a very clear contradiction. Therefore there aren't any solutions of this form. And yeah, that's I think that's pretty cool, right, in itself. So yeah, that's about as generalized as I could make it so far, but here I'm like constantly working on this problem in my head and stuff, in books too, yeah, but like mostly in my head, because I don't know, I like to do stuff in my head. But yeah, hopefully this is a slightly informative video, I guess, I don't know. Yeah, but this is like pretty cool, I think this is fairly cool. Anyways, yeah, pretty nice.